Hello all, let us see how to solve this particular problem. So basically what is given here is a op-amp circuit which is ideal. So and this op-amp basically has a positive feedback, and the input voltage provided is a sine wave voltage. The question is what could be the output voltage with the given input voltage. So here if you see the scenario, so op-amp can be used in two configurations. One is inverting input configuration and non-inverting input configuration. So the basic difference between inverting input configuration and non-inverting input configuration is that in the inverting input configuration, this Opamp basically applies a specific gain, and it stabilizes, the output stabilizes at a voltage which is multiplied by the gain of Rf by R1. Whereas if you take a non-inverting input voltage, we know that the gain is 1 plus Rf by R1. But what happens is the output is again fed back continuously to the input, because the output is also positive, right? When input is positive, output is positive in a non-inverting configuration. So output is fed back continuously, and the input increases with respect to this gain, and it saturates. Okay, so the main difference is that if a non-inverting configuration op-amp is used, when input is applied, it saturates. It saturates to a voltage such that when a high level is given, the maximum it can go is up to 5 volts. Okay, and then when the low voltage is given, because if the input is negative, the output will also be negative, and it goes more negative till minus 5 volts. So it saturates at minus 5 volts, whereas if it was a inverting configuration, what would have happened is it would have been V in into minus Rf by R1. So in a inverting configuration, when the input is positive, the output goes negative, and then if we assume a inverting, I'm saying, so, and then again this is fed back, and it will become lesser voltage, and that stabilizes when considering the RF and RI input resistances. So that is the difference. Now for this scenario, considering that op-amp is ideal and you are given a positive feedback, based on the rails that are applied, the voltage would either be plus 5 for any given input voltage. The output shall either be plus 5 volts or it shall be minus 5 volts. So if the input is positive, it will be plus 5 volts maximum, and if input is negative, it goes to minus 5 volts, and then again based on the sine wave, it again goes to plus 5 volts. So there will be two levels, plus 5 volts and minus 5 volts for this op-amp. So one has to remember that it almost acts similar to a comparator. So we know the functionality of comparator. Just to give you a glimpse of how comparator will work, so V1, V2. Okay, V2 will be reference. Generally we give some voltage. When V1 is greater than V reference, okay, that means plus is greater than negative, the V0 will be positive, which is equivalent to the saturation voltage of the op-amp. And then when V1 is less than V reference, V0 is 0, or the negative voltage that is applied. So this comparator functionality. So this particular circuit almost acts similar to a it just acts as a comparator. Thank you.